So the first thing we're going to try is something called a tactile simulation. We can't repeat the random process of returning phones to owners. Not everyone has the same phone. And also as a mother, the last thing I want you to do is dropping your phone on the floor and then picking it up. Bad things can happen. We also want to note how often zero matches happen in our simulation, or how many matches happen in general. So let's describe a tactile method using 4 cards. So I'm just using 4 regular cards we can use to simulate the random return process and thereby determine the probability of zero matches. So here I am. I have 4 cards here. I just had a random deck. My in-laws love to play cards, so we have decks everywhere. And I'm going to be, let's see, we've got a jack, an ace, a 7, and a queen. Sorry, these of course are flipped for you, but there we go. And I'm going to be the queen because I am the queen of statistics here, right? So how could I somehow simulate using these cards and pretending that I have 3 other people with me who can do this? Well, what I can do is I'm going to assign myself the queen, and let's say that I assign each of these other spots in front of me one of these cards. And then what I'm going to do is I'm going to shuffle these cards all up, not looking at them, so I can't see them at all. And I'm shuffling the cards, just shuffling away. And then I've got this back. I can't see what any of them are, and I'm going to deal them out. So I'm going to deal the first one to myself, and it happens to be the queen. Okay, cool. So I've got the queen. That's me right there. And then I'm dealing the 7 to the person beside me, and they happen to be the 7. And then the ace to the person across from me, but they're not the ace. And then finally, the last person gets the jack. So how many matches did we have? Well, we actually had 2 matches because I got my card and the person with the 7 got their card. So that's how that will work. And we would do this. Is it sufficient to do it just one time? Oh, no, 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 no. This would be many, many, many times to do this to simulate, because remember, probabilities in the long run. So let's go back to the notes and actually write down how this would work to simulate to hopefully get an estimate of or a value for the probability of zero matches. So let's talk about what we did. How would we break this down? So what's the first thing we did? Well, the first thing I did was steps. I assigned myself a card, and each of you, if we were in the classroom, would assign yourselves a card to do this with. Then we'd shuffle the cards, and each student would take a card, or someone would deal out the cards. But remember, you're shuffling, you're not looking at them, so that it's random who gets what. Each student gets a card. Then you're going to check to see the number of matches. So in this case, there were 2 matches. I got mine, and the person with the 7 beside me got theirs. And we'd record that. And then we repeat steps 2 to 3 many, 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 many times. Now in class, what we do when I'm doing a live class, we do it 5 times total. And then we calculate the proportion of those times where we got 0 matches. So using the method described in A, perform the simulation for a total of 5 trials and record your results in the table. Now, if you happen to have cards, it can be useful to do this, to try it just so that you're comfortable with the concept. But I'm going to just fill it in based on what I did myself. I'm not going to show you all of them because I don't think you really would probably care. But in terms of sitting here watching me do that, we saw, though, I showed you that when I did this, there were 2 matches. I matched and the other person matched. Well, when I did it again, I also got 2 matches. Excuse me. This time it was me and the person across. The next one, no one got their phone, in other words, their card. Then 2 people, again, got their matches. And then on the last trial I did, no one got their match. No one got their phone, so to speak. So based on the group's results, so my group, which I would have, there'd be a total of 4 of us. What's the approximate probability of 0 matches? Use the table below to summarize your data. So I'm taking this data and I'm going to summarize based on what I found. You're going to notice that this is trial 1, 2, 3, 4, 5. So we only did 5 trials. Here, this is number of matches. So how many times did we get 0 matches. And hopefully you're like, oh, that's 2. How many times did we get 1 match? Well, that never happened. How many times did we get 2 matches? Oh, that happened a total of 3 times. This total has to be 5, okay? So keep that in mind because there were 5 trials, therefore there has to be a total of 5 outcomes that we're looking at. This can never happen. You could just put a line through it because remember, we can't have 3 matches. And then we never had 4 people matching. So now, can I calculate this, the probability of getting 0 matches? And yes, that's going to be the 2 times out of the 5, which gives me 0.40. Now, to be a valid probability model, which we'll talk about in a moment, we have to account for every outcome. So the total for the probability has to be 1. Well, 0 divided by 5 is 0, and we've got 0, 0 here. 3 divided by 5 is 0.6, and of course you can use a calculator to do this. If you add across, you're going to get to 1, so it's looking good here. So we got 40% of the time we had no matches. Now in class, we would sit and take a moment and discuss this and see whether your probabilities are close to each other. And honestly, 5 trials is not that much. It's a pretty unstable in the sense of it's very low number. So there are a lot of times where I'll have maybe 5 groups out of all the groups in the class who had zero matches. So it looks like the probability is 0, but remember, we're talking over many, many, many such trials. The probability is close, usually not. I mean, there are a couple probabilities that match just because it's so few, but then there are people whose probabilities they're all over the place. They're anywhere between 0 and 1, which are the valid numbers, including 0 and 1. Now, what we would do is take a moment and then have you come up and report your numbers to the class. Well, I actually sat in on this class a number of years ago because I wanted to see how it was presented. And I actually, did this as part of the class. So it was kind of fun. And this is just everyone coming up and giving their numbers. The class count, 41 people out of all of the people that were out of all the trials, there were 41 that came up with 0 matches, then 26, 21, 0, and 2 for a total of 90. So there were a total of 90 flips. And then we just calculated this first proportion, 41 divided by 90, and I get 0.46. 0.46 is between 0 and 1 inclusive, in other words, including 0 and 1. If I was looking at percentages, remember we would move the decimal 2 points to the right, and that would be 46%. Using the combined class results, what's the probability of 0 matches? And we found it right here. Do you think this is a better estimate of the probability than the estimate obtained from one group's 5 trials, and why? I'd say yes, wholeheartedly it is. Remember, we're talking about probability of what happens in the long term over many such trials, such as the one we did in identical circumstances. 90 is a lot more than 5. Do I think 90 is enough to get me an exact probability, mathematical probability? No. If I did, let's say we did another 90 trials, do you think that we would get exactly 41 matches? No. Because remember, when you're doing this, these random processes, your outcomes are going to vary. Now, even better is the computer simulation. And we'll talk about that in the next video.